Hello everyone. So let's start solving some problems from Irodov. As in the previous class, I have already written down the question, so I'll just read it out and explain it to you simultaneously. So in the first problem, it has been said that there is an inclined plane which forms an angle alpha equal to 30 degree with the horizontal. So let me draw the inclined plane first. Okay, this is my inclined plane. Okay, and it has been given that this angle is 30 degree. This is the angle that the inclined plane makes with the horizontal. The mass ratio m2 upon m1 equal to eta equal to 2 by 3. Okay, so there is a figure which has been given to me. So there is a pulley. Okay, I think I can. Okay, alright, yeah. So I have the pulley and there are two masses. This is mass m1, which is attached to the pulley via string. So this is my mass m1. Okay, and there is a second mass m2 which is hanging from this side of the pulley. It's an ideal situation, so there is no friction from the pulley. Okay, and the strings are massless. It has been given to me that m2 upon m1, wherein m2 is the mass of this body and this is m1. Okay, it has been given to me that m2 by m1 is equal to eta, that is equal to 2 by 3. Okay, let me see what else has been given. The coefficient of friction between the body m1 and the inclined plane is equal to k, which is equal to 0.1. So between the mass m1 and this surface there is some friction, and the coefficient of the friction is given as k. Its value is 0.1. Okay, the masses of the pulley and the threads are negligible. I have already mentioned this. Find the magnitude and direction of acceleration of the body m2 when the formally stationary system of masses starts moving. Okay, so initially this entire system was at a state of rest and it was allowed to move. Okay, so once it started moving, I am supposed to find out the acceleration of this particular body. Okay, so let's for now assume that it was moving in the downward direction with an acceleration of, let's say, a. Okay, so let's say if my final answer turns out to be positive, then my directions assumption would be correct, and if it is negative, then in that case my directions assumption was wrong, which means that this body was actually moving in the upward direction. Okay, because right now as I have assumed the direction of acceleration as downwards. If my a turns out to be negative, it would just mean that my body was moving in the upward direction with an acceleration of a. The magnitude would still remain the same. Alright, so given this assumption, my mass m1 is moving in this direction, right? With what? With an acceleration of a. Okay, so let me try and draw the free body diagram given this assumption. Okay, so if I try to draw the free body diagram of m2, so this is my m2. So there is gravity acting downwards, gravitational force acting downwards. There is some tension by this string, right, in the upward direction. Okay, so this is my tension T by this string T, and this would be the direction of the tension on this mass m1, right? So these are the two forces which are acting on M2, and under the influence of these two forces, this M2 is supposedly moving downwards with an acceleration of A. Okay, now let me try and draw the FBD of the mass M1. Yeah, yeah. So here there is this tension, right? There is tension. Let me shift it here. Okay, this is the tension. And what else? There would be some frictional force, right? And there would be a component of the weight acting along the inclined plane as well. So if I think about the frictional force, its value would be, its direction would be down in the downward direction, that is opposite to the direction this mass m1 is moving relative to the inclined plane, right? So its value would be k times the normal force. The normal force is nothing else but m1g cos of alpha, right? This is the normal force, right? Let me draw that as well. But I wouldn't want to draw it in this FBD. This is my mg, right? This angle is alpha, which means that this angle is also alpha. The normal force magnitude is mg cos of alpha, and there is a force component of mg along the inclined plane. Its value is mg sine of alpha, right? So this is what I'm using, the normal force, to find out the magnitude of the frictional force, right? And apart from these two forces, there is one more force, that is the component of m1g along the inclined plane, right? And its magnitude is nothing else but m1g sine of alpha, right? Okay, let me delete this part. So given these two FBDs, I can write down some force equations. So from this FBD I can write down one equation that would be m2g, because I've assumed downward as positive. This is positive, so all the forces acting in the downward direction will have positive coefficient, and minus t, since t is acting upwards, this is the net force, and under the influence of this net force, this body m2 is moving downwards with an acceleration of a. So this is my first equation, right? And if I try and write down the equation for this body, okay, I'll assume this as my positive direction. So all the forces that are acting along this direction would be positive. So I'll write down t minus m1g sine of alpha, okay, minus k times m1g cos of alpha. If I put that term in bracket, I'll write it down like this: k times m1g cos of alpha. This is the net force. Under the influence of this force, this body of mass m1 is moving along this direction, right, with an acceleration of a. Okay, I should have mentioned the direction of the acceleration as well. Yeah. So under the influence of all these forces, this body of mass m1 is moving along this direction with an acceleration of a. Okay, so this is my second equation. What am I supposed to find out? I am supposed to find out the value of a. Okay, alright. From these two equations I can straight away cancel my t, right? If I just add 1 and 2, this will give me m2g minus m1g sine of alpha plus k times m1g cos of alpha. This would be equal to a into m1 plus m2. Okay. This implies, let me shift this entire question a bit downwards. This simply implies g times m2 minus m1 sine of alpha. Am I writing it correctly? Yeah. Minus k times m1 cos of alpha. This is equal to a into m1 plus m2. Okay. If I divide this LHS and RHS by m1, I'll get g into eta minus sine of alpha minus k times cos of alpha. This will be equal to a into eta plus 1. Okay, because m2 by m1 has been given to me as eta, right? Whose value is 2 by 3, right? If I bring in eta plus 1 on the LHS, I will get a as this, right? So this is going to be the expression of a in terms of g, eta, and alpha and k. Okay, if I put in all the values, I'll get a nearly equal to I think 0.05 g. Yeah, 0.05 g. Okay, so you basically need to focus on the concept, and this is what the concept was. We basically had to write down the FBD, draw the FBD, and write down some force equations based on the FBD. Okay, alright. Let's move on to the second question. This was my first question. Let's move on to the second question. So in the second question also I have a figure based on which I'll explain the problem. So let me draw the figure first. So in the second problem, okay, I have a pulley. Okay, which is attached to a ceiling. This is my ceiling. This is how my pulley is attached, and there is a big rod, okay, whose length is L. Okay, this rod is connected to my string, to my pulley via this string. Okay, its length is L, and its mass has been given to me as capital M. Okay, and on the second part of the string I have a ball. Okay, initially this ball is at the lower end of the rod, and this ball has a mass of M, and it has a circular hole, okay, from which this thread can pass. There is some friction between the thread and the surface of this ball. Okay, but this ball is able to move through the thread, okay, under the influence of some frictional force. Okay, so let me read out the question now, since I have drawn the diagram. So there is a mass of rod, there is a rod of mass capital M, which exceeds the mass M of the ball. Okay, the ball has an opening permitting it to slide along the thread with some friction. I've already explained this part. The pulley is idle. Okay, at the initial moment the ball was located opposite to the lower end of the rod. I've already explained this part. When set free, both bodies began moving with constant acceleration. Find the frictional force between the ball and the thread if t seconds after beginning of the motion the ball got opposite the upper end of the rod. The rod length equals L. Okay. So it has been mentioned that once this entire system was set free, these two bodies started moving with constant accelerations, right? So let's assume that this rod started moving down with an acceleration of a1. Okay, and mind you, this ball is not attached to the thread. This ball is going to move under the influence of some frictional force between the ball and the thread, and this frictional force is actually going to force it to move in the upward direction. Okay, so let's assume that it is moving in the upward direction under the influence of the forces that is acting on it. Let's say that its acceleration is a2 in the upward direction. Now let me draw FBD of both these bodies. So this is my capital M, and there is a force acting downwards, capital MG. There is a force acting upwards, sorry, its value is T, and under the influence of these two forces this rod is moving downwards with an acceleration of a1. Okay, its length is L. Okay, and this is my ball. Okay, the forces that are acting on it is some frictional force. Let's say it is F. Okay, and there would be its weight acting in the downward direction. It will be M into G, and we have assumed that it is going to move under the influence of these forces in the upward direction with an acceleration a2. Okay, it has been mentioned that after time t, this ball came to a point which was exactly opposite to the top of this rod, right? So effectively, with respect to this rod, this ball moved a length of L in time t. That is what happened. Okay, so let me write down the force equations now, and there would be a third equation which would also be coming up. So for this body, my equation would be capital M G minus T equal to capital M into A1. Okay, let's say this is my first equation, and for this ball my equation would be F minus mg equal to M into A2. This is my second equation. Okay, and what would be my third equation? So with respect to this rod, this ball is going to move in the upward direction, right? Upward direction with an acceleration of a1 plus a2, right? So with respect to the rod, the ball will move in the upward direction with a relative acceleration of a1 plus a2, and in time t it would have covered a distance L. Okay, so we can straight away write down the second equation of motion. So L, that is the total displacement of the ball with respect to the rod, which is L, is equal to half times the acceleration of the ball with respect to the rod, that is a1 plus a2 into t square. This is my third equation. Alright, so I have one equation, this is my second equation, and this is my third equation. Okay, by the way, will this F and T be the same? It will be the same. Okay, why? Because if the string is actually pulling this ball via frictional force, right? But this ball would also be pulling the string by the same amount of force, right? Basically action and reaction pair, right? So which effectively would be the tension. If this ball was not there, let's say if there was no friction between the ball and the string, and since the ball was not attached to the string, the tension would have been zero and this body would be freely falling. Okay, so it's actually the friction which is causing tension in the string. Okay, so I can write down one more equation, that is F equal to T. Okay, let's say this is my equation 4, and let me remove this T and replace it by F. Okay, using this equation 4. Okay, so using these three equations I can find out the value of F, because I have three equations and three unknowns, right? And if I have three equations and three unknowns, I can find out any of the unknowns. Okay, so if I add, sorry, yeah, let's add these two equations, right? The first equation and the second equation. All right, what will I get? G minus F by capital M plus F by small m minus G equal to A1 plus A2, and I can replace A1 plus A2 by 2L divided by T square, right, from the third equation. So effectively G and G gets cancelled. If I take F out as common, I'll get 1 by M minus 1 by capital M equal to 2L by T square. Okay, which gives me the value of F as 2L into capital M into small m divided by T square into capital M minus small m. This is what my frictional force will be in terms of an expression. Okay, expression in terms of L, capital M, small m and T. Alright, yeah, so these are the two equations, these are the two questions that I solved today. We'll come up with more problems in the next class. Alright, bye.